Alright, so in this recording we're going to talk about what exactly geography is, which actually becomes quite a bit more complicated when you start to think about it, and why geography is important, because, we should justify why we're, sitting here talking about geography. So most basically, geography is the study of space. It's a study of where things are in the world. It's a study of patterns, why things are where they are relative to one another, like why is something near to this thing but not to that thing. It's a study of movement of things around the world, and it has a big temporal element as well. And geography is it's a bridge discipline, but an oddball discipline in many ways, because it bridges the human and the physical, because the thing you're studying that is somewhere on Earth can either be a human or physical phenomena. It could be a species of tree, it could be something like water quality changing over in different parts of the world. It could be an economic factor. It could be a, social factor, a historical factor. There is, what you study in geography is, pretty much limitless. So as a result, geography is very interdisciplinary and bridges the gap between human and physical. So, one definition for geography that is used quite commonly, and you've probably heard if you've taken a high school geography course, is the what's where, why there, and why care definition by Charles Gritzner. What's where, again, refers to that idea of figuring out where things are on the Earth. Their locations, patterns, movement, interaction, variation across space. Mapping things out, basically. So that's, once you've done that, you have to figure out why things are distributed the way they are across Earth. And so once you have your, say, map or other graphic that shows you where things are, you have to explain it. And this is often done by leveraging the expertise of other disciplines, which will obviously depend on what you're studying. If you want to understand why trees are the way you are, you want to talk to a biologist or an ecologist who knows about trees and what conditions they prefer, both on a micro and macro planet scale, for example. Or if you want to understand why, some neighborhoods are wealthier than others, you might want to talk to an economist or a historian. And, of course, the last question is, why care? Why are we doing this research in the first place? Why is it useful? How does it help other people? Because, geography is often studying complicated issues, and because the world is so interconnected, even, looking at a physical study like soil quality can impact people by, through agriculture and food insecurity and things like that. So how do we answer each of these questions? Well, starting with what's where, we can use spatial data. Spatial data is just data with a spatial component or a location. And your location information can be either quantitative or qualitative. You can have something like coordinates, longitude and latitude, an address, neighborhoods, which, are more qualitative, abstract units of location. You can have routes, trips, roads, landscapes even. And you can collect this data in a variety of ways. You can collect it through field observations, measurements, notes, sketches, and photographs, going out there and collecting information either with pen and paper or increasingly on your phone. You can conduct interviews with people. You can set up field experiments. You can do surveys that people fill out. You can even use remote sensing, which is using satellites or drones to collect information about an area without actually directly interacting with the area. And this allows you to cover, a much bigger area with your study than you could if you were just to, walk there. If you wanted to do a study of snow cover across the entire Canadian Arctic, be a lot easier just to have a satellite fly over a few times rather than, somehow walk across the entire Canadian Arctic, which would be near impossible. And many studies today involve taking pre-existing spatial data that was collected by researchers for previous studies, governments, private sector, whatever the case may be, and sort of reanalyzing it or comparing it to other data sets to generate new research and findings. A lot of government data is actually open to the public through open data portals and thus is extensively used in research. So now that you have your spatial data and you've answered your what's where question, we now have to figure out why things are the way they are. We have to find some factor. We have to establish causality, cause that explains the effect, which is the distribution of things across the earth. And this is very difficult in geography, misleadingly difficult in fact, because the world is such a complicated place. Like, for every landscape, for every place, there are, hundreds of variables that go into making it look the way it does. Some methods that are used to answer the why there question include interviews. In human geography, you can, ask people why things are the way they are, why they make certain decisions, do things the way they do them. You can use statistical analyses and modeling, which of course can establish correlations, but you need more information to determine if those correlations are, establish a cause and effect, or if, some other third variable is the cause of, influencing the two variables you're looking at. You can now, instead of using traditional statistical analyses, you can do spatial analyses using GIS, taking into account location when you're doing your statistics. You can do experiments in a lab, and you can draw upon the research and teachings and knowledge from other disciplines to help you understand your geographic question. Now, the approach I like to take with geography, I call Socratic geography, which is essentially applying the Socratic method to geography. And if you're not familiar with the Socratic method, basically how it works is somebody asks you a question, you answer, and then the person who asked you the question asks you another question about your answer to try and dig deeper. And this process repeats itself until you find a question that you can answer. And then, your research is going out and finding the answer to that question. So an example would be looking at volcanoes. So somebody could ask, hey Ben, how do volcanoes work? Well, I would say, you have hot buoyant magma rises to the Earth's surface, erupts, forming lava, and then you get a volcano. But then you could ask, well, in that case, there's why is there magma and why is there volcanoes only in certain parts of the world? Why wouldn't that happen everywhere? Why is magma more buoyant than the other rock, and how does it get through so much rock to get to the surface? How is magma formed in the first place? Why are certain volcanic eruptions explosive while others are not? Why do we get different types of rock from different volcanoes? And there's a million different questions about volcanoes, and to answer them, then eventually you have to drill down into the chemistry and physics of how magma and volcanoes work, and eventually you get to a question that you can't answer about volcanoes, and you have to go to research. So geography not only provides you with a good occasion, a good reason to learn about other disciplines like chemistry and physics, as I said there, or maybe economics if you're answering an economic geography related question, or so on and so forth. But it's using this method is a great way to quickly arrive at a question that you don't know the answer to, and then you can start the research process. Now the last question, and arguably the most important one, and arguably the most difficult to answer, is your why care question. And to answer this, I like to take advantage of the fact that the world is an incredibly interconnected place. So, for example, you can look at something like soil health, and you can connect that to agriculture, which then connects to food security or insecurity. So you could do just a soil survey, and you could justify that by saying, well, we have to assess something like the nutrients in the soil or the rate of soil erosion, and because that has implications on our ability to grow enough food to feed everyone. Similarly, you could look at the economic conditions in a place, and you could justify that by saying, well, we're looking at spatial inequality either within countries, like this map here, which shows wealth inequality, or even between countries as well. So it's important to and useful to use these interconnections between the natural and the human world to justify why you're doing certain types of research, because ultimately your goal is to help people and help the planet.